What happens when a hydraulic hose fails? Well, we mentioned with the raw material costs going up and the labor costs going up. So when you have downtime, that downtime cost could be in the hundreds of thousands, if not $1 million a day, depending on the application. So, think about your operation. Think about one of your major pieces of equipment. What happens if that goes down for the day? How much downtime cost is that? Everything else that goes along with hydraulic hose failures, with system pressures being higher, system temperatures being higher. So now collateral damage is a bigger concern. Public safety is a bigger concern. A couple people already talked about sustainability and the environment. So there's environmental damage concern as well too with these fluids that are, what if you blow a hose and you got liquid or oil that drops into a water reservoir of some sort. So all those are consequences of when a hydraulic hose fails. If you were to use a time-based maintenance system, when would you pick to replace the hoses? If you want to be very conservative, you could pick the line at the left. But you see, when you pick that line, you're still throwing away a lot of good, useful hose there. If you want to take the average life, then you can pick the line at the right. But with that, you're still going to have failures from hoses 2 and 5. And then you're still throwing away good hose from hoses 3 and 4. Now, the benefit of having a true hose conditioning monitoring system is, as it goes from light blue to dark blue, that's when you know that failure is starting to occur, and you can replace that hose before it ultimately fails, thus using the full useful life of the hose as well too. One mega trend out there happening right now is called the Internet of Things. Just quickly by a show of hands, who has heard of the Internet of Things mega trend? So a handful of people. In essence, what it is the objects, say it's a pump or hose or whatever, this object is now embedded with these electronics, which would consist of hardware, software, firmware, and some type of network connectivity. And then with these objects, you're now able to communicate to the cloud. And once that information is in the cloud, then you can do data analysis with it, you can give commands with it, and the benefits of all this really helps you streamline your operations. Your machines are talking to each other. You're potentially able to adjust the system performance by knowing how it's operating. You could be doing that in California on a piece of equipment that is operating in Ohio. So that's what this whole Internet of Things is about. It's just the communication of information on components and machines out there that's communicating information to the cloud. And this is an example of what that type of network infrastructure would look like. So as I mentioned, you got the objects on the bottom. They would have sensors on those. Those sensors then communicate to a gateway, and that gateway then communicates out to the cloud. And all this information goes to this database, and then once that information is there, you can do with it whatever that you want to do with it. You can send notifications to whoever you want to send a notification to. You can do, as I mentioned, that data analysis. So this is an example of what that architecture can look like. So what types of products are out there that have this type of capability? And so any one product that we have is called LifeSense, which is a true hydraulic hose condition-based monitoring system. And that's just what we're able to do, is we're able to monitor the hose, and when the hose starts to break down, we're able to detect that, provide a notification so that the hose can be replaced before it actually fails, so that you don't have the consequences of downtime, so that you don't have collateral damage, safety concerns, environmental concerns, everything above that we talked about with what happens when the hydraulic hose fails.